On this problem, we're going to find all kinds of information to graph this function. We're going to find the domain, the x and y intercepts. We're actually going to find the asymptotes also. So let's start with the domain. Now with the domain, what you want to focus on when you have a rational function is the denominator. The denominator cannot be 0. So in this case, x cannot be equal to 0. So what that's saying is, if you just think of a number line, it's going to exist everywhere except at 0. So it's going to exist everywhere to the left and everywhere to the right, but it's not going to exist at 0. So your domain is going to be negative infinity to 0. Since 0 isn't included, we use parentheses, and then it's going to take off from 0 and go again to positive infinity. But 0 once again isn't included, and we use the union symbol to join these two intervals for the domain. Now, keep in mind that we know where x doesn't exist. That's also where we have a vertical asymptote, which is where the denominator equals 0. So where the domain doesn't exist in this rational function is also where we have a vertical asymptote, x equals 0. Now we're going to go ahead and find the x intercepts. And when you find the x intercepts, you set the numerator equal to 0. And when you do that, negative 7 is the numerator, set equal to 0. And that's not true. So that means there are no x intercepts. Now to find the y-intercept, you replace x with 0. So you find f of 0. So when we do that, we substitute negative 7 or 0 in for the x, and negative 7 divided by 0 is not possible. It's undefined. What that means is there's no y-intercept. So now let's find the horizontal asymptotes, if there are any. Now when we do the horizontal asymptote, we look at the degrees, and the degree is the exponent. I'm going to go ahead and write the function down again, which is negative 7 over x. Yep. And the degree at the top, if you notice, we don't have an x, which means that the degree of a constant term is 0. If we did have an x, it would be x to the 0 power. Then on the bottom, our degree is the exponent on that x, which is 1. So anytime the top is less than the bottom, because 0 is definitely less than 1, now what that means is that y equals 0, or the x-axis is a horizontal asymptote. So y equals 0 is a horizontal asymptote. And since the numerator was not greater than the denominator, we have no oblique asymptotes. So as of right now, all we know is we have the domain from negative infinity to 0, 0 to infinity, 0 not included, which means we have a vertical asymptote there, and we have a horizontal asymptote of y equals 0. So now what I'm going to do is sketch the graph. I'm going to use blue for the asymptotes. We have a vertical asymptote of y equals 0, which is the vertical asymptote of x equals 0, and a horizontal asymptote of y equals 0. So the only question that remains is, since the general shape of these rational functions are like that and like that, we got to determine is it up there, down there, up there, down there. So we can use a graphing calculator to help us out a little bit. If you don't have a graphing calculator, you can always substitute points into the original function just to get an idea. So we're going to type in negative 7 divided by x, graph it. It goes up and it's up there, so let's graph it. Notice some things. It's not crossing the x or y axis. We already know that because there's no x or y intercepts. It's approaching the x and y axis because both of those are asymptotes. And normally it would look like that, but notice the reason why it's up in the second quadrant and the fourth quadrant instead of the first and third is because of the negative. And that's why it flips it. Flips it over the x-axis. Now, how much do I want to show you in the calculator? Okay, I'll show you some stuff. As far as the asymptotes go, the vertical asymptote, you can always look at the table. Not always, but sometimes it tells you y equals 0, or x. When x is 0, y is undefined. So that means you have a vertical asymptote. The domain doesn't exist there. Intercepts. There's no y-intercept because when you substitute x in, x for 0, you don't get anything. So there's some things you can determine on the graphing calculator.